terminal, I just want to show you the resistance changes. Let's come to this camera. I've already turned on the multimeter device and put it on resistance to read only the ohm. I've just chosen the scale 200, which is enough. As you know, the sensors here are PT100 and show a resistance of 100 ohms at zero temperature. The ambient temperature now is about 20 degrees centigrade. If I want to implement a linear ratio, the sensor must show a resistance of 110 or 112 ohms. If you look at the red wires, both sides are taken from one side of the resistance and connected to it, and this side is taken from the other side of the resistance. I take these two terminals together. Now you can see the resistance of 109.6 or 110 ohms. Let me try on this one too. As you can see, there's no difference. In fact, the resistance of both sides is the same. I mean 109.6 or 110 ohms. I want to hit the sensor head to see the resistance changes. Actually, I want to do it simultaneously. I hit the sensor head. As you can see, the resistance moves upward. So, in fact, the change in temperature increased the resistance. As you know, the RTD sensor shows the resistance of 138.5 ohms at 100 degrees centigrade. As you can see, it is approaching 90 degrees of centigrade. Please turn off the flame, thank you. Now I can almost say that the center temperature is about 120 or 130 degrees centigrade because the resistance increased. Now I want to have a current output to see the milliampere changes. That's why I used a power supply. I've implemented a 24 volt DC power supply here. And as I can see, the output is 23.8 volt, which is quite clear here. I put a multimeter in the circuit. I took the output from both positive and negative. To do the connection, I did this. As you can see, the red wire from the positive side of the power is connected to positive terminal of this equipment. And this one is the negative side and connected to this part. And the other side is connected to the power negative terminal, power supply negative terminal. It's obvious that this device is series inside of the circuit. If you look at the current output, it is 9.6 milliampere that shows the current changes. Because the sensor was already hot, the current change is 9.6 milliampere. Otherwise, it should have shown a current of about 7 or 8 milliampere, which is equivalent to room temperature. I want to hit the sensor again to see whether the milliampere increases. So I hit this part again. If I look at the output, I expect the output to be higher. If you look at the milliampere, it moves upward very fast. And I can see the temperature changes on RTD. So thanks a lot. I think it's enough. In next step, I want to use a thermocouple sensor instead of an RTD sensor. Please stay with us. Thank you.